Okay, here are the solutions for the first three questions of that worksheet to see how you're doing if you are confused. So we're going to go through this relatively quickly because you've already seen a few examples in detail, so I'm going to try to kind of zoom through these so you can see what the thinking is. But potassium permanganate, aqueous solution, so I have K positive aqueous, I have permanganate is MnO4 minus. I know this dissolves because potassium is group 1, and everything group 1 dissolves and dissociates. Was reacted with an acidic, acidic means I have H positive aqueous, that's cool. Of sodium bromide, got a little bit of Na positive aqueous there, because again, sodium is group 1, it dissolves. Bromide is Br minus aqueous. And then finally, I know that I always have the waters, H2O liquid as well. As soon as I see permanganate and acid, I know what my OA is. If I go to this, this right here, I know that this is going to be my SOA, right? I have my permanganate, my 8H positive. So MnO4 minus aqueous plus 8H positive aqueous plus 5 electrons. Whoa, don't know what I did there. Gotta erase that. Yep. Makes for me Mn2 positive aqueous and 4 H2Os. Okay, so that is my reduction half reaction. Now what else do I have here that could be oxidized? Let's label this as my SOA, so I'm keeping track of that. So what do I have that actually gets oxidized here? Well, if I look through of all my different options, I actually end up with an SRA, probably of bromide is my lowest one, which is shameful because it's actually really high up. But I got a really strong oxidizing agent, so this still is actually spontaneous, but that is the first thing that I come to that I have as an SRA. So that's my reducing agent, which means that my oxidation half reaction is 2Br minus aqueous makes 2 electrons and Br2 liquid. And actually the bromine is the reason why I get an orange-brown substance being formed. That's trying to give you a little bit of a hint there. This is very much spontaneous. Yes, when we took a look, that was very, very downhill. I'm going to need to multiply this by 2 and this by 5 because 2 and 5 meet up at 10. So I'm going to get 10 electrons on both sides to make this work. So that means that I'm going to end up with 2 MnO4 minus aqueous plus 16 H positive aqueous plus 10 Br minus aqueous makes 2 Mn2 positives plus 8 waters and 5 Br2s. Double check time. I want to make sure that everything works out to the same charge. So I have -2 right here. I have positive 16 right here. I have -10 right here. So that means in total I've got -12 plus 16, positive 4 as a charge on the left. Then on the right, I just have only one charge thing. That brings me positive 4, 2 times 2. So I know that I'm good. This works out. The charges are balanced on both sides. So I'm pretty confident that this is a good answer. So this is spontaneous because of the fact that it's downhill. All right, that was number 1. Moving on, number 2. A strip of silver metal. All right, so I got Ag solid because I have silver. It's placed in a solution of aqueous nickel 2 chloride, and it already says it's aqueous, so I know that it will dissociate because this is ionic. So I'll get Ni2 positive aqueous. I have Cl minus aqueous. And then, of course, I have water. Always the water. All right. So now let's take a look and see what I have for OAs and RAs. Nickel 2 chloride, got some good stuff. So for my SOA, nickel 2 is actually where it's gonna be at. That's my strongest OA down here, but that's what I got. So nickel 2 is my SOA. And then after that, I've got as an SRA going from the bottom. Well, there's my silver right there. So that's what I have for an SRA. Now this is actually going to be non-spontaneous, but this is my SRA. Okay, so my reduction is Ni2 positive aqueous plus 2 electrons gives me solid nickel. That's a very ugly N. And then I have Ag solid makes an electron and Ag positive aqueous. In order to make this work, I need to multiply that by 2. So now I can combine into my net, and I will end up with Ni2 positive aqueous plus 2 silvers makes Ni solid and 2 Ag positive aqueous. I already determined that this is non-spontaneous based on the fact that it is uphill between my OA and my RA. I know that. And then in terms of the charge, this is 2 positive on the left, and it's 2 times 1 is 2 positive on the right, so I got a good answer here. Okay, number 3. We are getting to the end of these examples. Liquid mercury, well, it's telling me the state already, and it's an element, so I just kind of already know what it is. Hg liquid is mixed with a paste of acidic manganese 4 oxide. This is weird terminology that appears around manganese 4 oxide often, and that means for paste that it's actually like a solid suspended in the water. So I actually have MnO2 solid, and then I have water, of course, as well. But the paste word is actually saying I have some solid. Okay, kind of like a toothpaste, right? You got a bunch of solid in there, abrasives. All right, so that's what I have for my major entities. MnO2 and H positive is going to make up my SOA. And it sucks that those emails are showing up in the corner. So anyways, what I've got here is, I'm going to actually go to this slide. I've got MnO2 solid and 4H positive. That is my SOA that I'm looking at. And then mercury is going to be my SRA, which when I go down from the bottom right, I work my way up. I'm going to find mercury right around here. So actually, there's very little difference in height between the two, but that is downhill. So I've got MnO2 solid plus 4H positive aqueous plus 2 electrons makes Mn2 positive aqueous and 2 H2O liquids. Okay, and then when I take a look at the other, the SRA that I'm looking at, I've got Hg liquid, so that's going to go Hg liquid makes Hg2 positive aqueous and 2 electrons. So I've got 2 and I've got 2. That's going to cancel out. It's all good to combine. So now what I have is I have MnO2 solid plus 4H positive aqueous plus Hg liquid makes Mn2 positive aqueous, 2 H2O liquid, and Hg2 positive aqueous. This was downhill, so I know this is spontaneous. Quick check on charge to make sure I'm right. On the right or left-hand side, sorry, I have a 4 positive charge, 4 times 1. And then on the right, I have 2 positive and 2 positive, so I have 4 positive as well. So I know that I'm correct. Looks like a good solution, so I am done. All right, so hopefully that helps going over a few examples. Any questions you have, again, just leave it as a comment to the lesson, and we'll go from there. All right, have a good rest of your day.